1. What is a logical address space? A. The physical memory addresses accessed by a program. B. The virtual memory addresses used by an operating system. C. The addresses of I/O devices in a computer system. D. The network addresses used for communication between computers. Your time starts now. 5, 4, 3, 2, 1. Answer: B. The virtual memory addresses used by an operating system. Explanation: a logical address space refers to the set of virtual memory addresses used by an operating system. It provides a uniform addressing scheme that is independent of the underlying physical memory. 2. Which component is responsible for translating logical addresses to physical addresses? A. Central Processing Unit, CPU. B. Memory Management Unit, MMU. C. Hard Disk Drive, HDD. D. Random Access Memory, RAM. Your time starts now. 5, 4, 3, 2, 1. Answer: B. Memory Management Unit, MMU. Explanation: the MMU is responsible for translating logical addresses to physical addresses using techniques such as page tables or segmentation. It maps virtual addresses to physical addresses in the memory hierarchy. 3. What is the purpose of a page table in memory management? A. To store the physical addresses of each memory page. B. To keep track of the usage statistics of memory pages. C. To provide a mapping between logical and physical addresses. D. To allocate memory pages to different processes. Your time starts now. 5, 4, 3, 2, 1. Answer: C. To provide a mapping between logical and physical addresses. Explanation: a page table is used in virtual memory systems to provide a mapping between logical addresses, virtual addresses, and physical addresses. It allows the operating system to translate a virtual address to its corresponding physical address. 4. Which of the following is true about logical address spaces? A. They are always smaller than physical address spaces. B. They are independent of the underlying hardware. C. They are fixed in size and cannot be expanded. D. They directly correspond to physical memory locations. Your time starts now. 5, 4, 3, 2, 1. Answer: B. They are independent of the underlying hardware. Explanation: logical address spaces are independent of the underlying hardware. The operating system maps logical addresses to physical addresses using memory management techniques, allowing the program to use a consistent addressing scheme regardless of the hardware configuration. 5. In a demand-paged virtual memory system, what happens when a page fault occurs? A. The operating system terminates the program. B. The operating system swaps out a page from memory to disk. C. The operating system loads the requested page from disk into memory. D. The operating system allocates additional physical memory for the program. Your time starts now. 5, 4, 3, 2, 1. Answer: C. The operating system loads the requested page from disk into memory. Explanation: In a demand-paged virtual memory system, a page fault occurs when a requested page is not present in memory. The operating system then loads the required page from disk into memory to satisfy the page fault. 6. Which of the following is a disadvantage of using a pure segmentation memory management scheme? A. Fragmentation of memory. B. Difficulty in implementing address translation. C. Limited address space for programs. D. Inefficient use of disk space. Your time starts now. 5, 4, 3, 2, 1. Answer: A. Fragmentation of memory. Explanation: pure segmentation suffers from external fragmentation, where free memory is broken into small non-contiguous chunks. This fragmentation can lead to inefficient memory utilization and can make it challenging to allocate contiguous memory blocks to processes. 7. Which memory management technique allows multiple processes to share the same physical memory locations? A. Paging. B. Segmentation. C. Swapping. D. Overlays. Your time starts now. 5, 4, 3, 2, 1. Answer: A. Paging. Explanation: paging allows multiple processes to share the same physical memory locations by mapping different logical pages to the same physical page frames. This enables efficient memory utilization and facilitates memory sharing among processes. 8. Which of the following statements about the logical address space of a process is true? A. It remains constant throughout the execution of the process. B. It is limited by the size of physical memory. C. It includes both the code and data segments of the process. D. It is the same as the program counter value. Your time starts now. 5, 4, 3, 2, 1. Answer: C. It includes both the code and data segments of the process. Explanation: the logical address space of a process typically includes both the code segment and the data segment. The code segment contains the instructions of the program, while the data segment contains the program's variables and data structures. 9. What is the purpose of address translation in a virtual memory system? A. To translate logical addresses to physical addresses. B. To convert virtual addresses to cache addresses. C. To convert physical addresses to logical addresses. D. To translate logical addresses to network addresses. Your time starts now. 5, 4, 3, 2, 1. Answer: A. To translate logical addresses to physical addresses. Explanation: address translation in a virtual memory system involves converting logical addresses, virtual addresses, used by a program to their corresponding physical addresses in the underlying physical memory. 10. In a segmented memory management scheme, which of the following is responsible for keeping track of the segment sizes and base addresses? A. Page table. B. Segment table. C. Translation look-aside buffer, TLB. D. Memory Management Unit, MMU. Your time starts now. 5, 4, 3, 2, 1. Answer: B. Segment table. Explanation: In a segmented memory management scheme, a segment table is used to keep track of the segment sizes and base addresses. The segment table is consulted during address translation to determine the physical address corresponding to a given logical address within a segment. 11. What is the advantage of using a virtual memory system with a logical address space? A. It eliminates the need for secondary storage. B. It provides a larger address space for programs. C. It reduces the number of page faults. D. It improves the speed of CPU execution. Your time starts now. 5, 4, 3, 2, 1. Answer: B. It provides a larger address space for programs. Explanation: One advantage of using a virtual memory system with a logical address space is that it provides a larger address space for programs than the physical memory can offer. Virtual memory allows programs to address more memory than what is physically available by storing infrequently accessed data on secondary storage. 12. What happens if a process accesses a logical address that is not mapped to any physical address? A. The process is terminated by the operating system. B. The process generates a segmentation fault or a page fault. C. The process is moved to the swap space on disk. D. The process continues execution without any issues. Your time starts now. 5, 4, 3, 2, 1. Answer: B. The process generates a segmentation fault or a page fault. Explanation: If a process accesses a logical address that is not mapped to any physical address, it typically results in a segmentation fault or a page fault. This indicates an error in the memory management process, and the operating system handles it by terminating the process or loading the required page from disk into memory.